Hello, my name is Bill Doran, and this is my lab report for lab number 1. Introduction to this lab. This lab teaches us about the concepts, measurements, and observable practical effects of an object's net charge, the concept of electric field and electric force. What we learn is that when different actions are taken on a piece of Scotch tape, the pieces of tape can acquire a net negative charge or a net positive charge. And it is possible to design a simple experiment that takes one measurement, which is length, using a ruler, to determine with a very impressive level of precision the net charge on a piece of tape, simply by recording the differences in the displacement of the tape. This experiment, like I said, only uses one measurement really, which is using a ruler, and uses the equations and constants we've learned in physics, and only a few simple assumptions to get us to this end result. And this process teaches us how to see the practical application of the concept of charge, which can be sort of hard to visualize in real life. So this is just a line of reasoning that brings us to the conclusion that the tape is positively charged. Basically, if I have a negatively charged pen, and the tape is attracted to the pen, it would be positively charged, and vice versa. If it's negatively charged, it would repel the pen, because that would mean that they are like charged. When I did this experiment, the tape attracted the negatively charged pen, which led me to the conclusion that the tape is positively charged. And here is the actual experiment. There's a diagram here showing the system. Tape B is what is floating above tape A when you hold it up. Both of them are charged pieces of tape. And since the momentum of tape B is not changing, we can determine that the net Y component of the force on tape B is 0, which means that the electrical force from tape A is equal. The magnitude of the electrical force of tape A on tape B is equal to the magnitude of the force of gravity on tape B, which is actually pretty easy to measure. Calculating the force of gravity is not too hard to find, which leads me to the calculations. By using the length of the tape, I'm able to find the mass number, as you can see in the top right. And here's my simple force of gravity calculation, which is right here, 0.001862 newtons. Then using that number and an equation for the electric force, we are able to find how to calculate the charge of the tape B. As you can see right here, that ends up being 1.319 times 10 to the negative 8th coulombs. Continuing on, we're able to find the actual number of deficient electrons by simply dividing that charge by this constant E, which is the charge of a proton, which is the charge that in theory the tape is gaining every time it loses an electron. So we are able to find that the tape is losing 8.244 times 10 to the 10th electrons. Right here we calculate the number of atoms on the sticky surface of the tape by simply dividing the area of the tape by the area of a single atom, and we find 3.8 times 10 to the 17th atoms on the sticky surface, and that leads us to a very simple ratio calculation of deficient electrons to the number of atoms, which we get to be 2.169 times 10 to the negative 7th. Here's the code. It was a relief to see that I got the exact same numbers as when I did the calculations by hand. In this visualization here, the red ball is tape A, the blue ball is tape B, and the green arrow is the electric force, and the orange arrow is the force of gravity. So there are a few assumptions. I treat the tape like a 2D object, not a 3D object with thickness, when I compute the number of atoms in the tape. And I also assume that the atoms are square shaped, with equal width and length. I also assume each piece of tape has the same net charge, and I treat each piece of tape as if all of the charge in the tape is concentrated at one point in the center of the tape. In conclusion, answering these final questions, if the charge of electrons and protons were switched, it would not change the observations at all, because like charged objects would continue to repel each other and different charged objects would continue to attract each other. And it's important to handle the tape as little as possible, because the charge can easily transfer onto hands or other objects when they come into contact with those objects. Thank you.